Now in a whole mess with flying cables directly from the battery, with the vacuum pump connected to the fridge, and she's showing this when I stopped it. Now we open the valve. Let's see. Nothing's changed. So we have a good vacuum after 3 hours. After standing 3 hours to see if there's any air that's going inside the fridge circuit. So the weldings is like a dirty hack, a piece of tubing welded from one side to the other side, and the small capillary tubing put inside the other one and welded. The whole compressor, it's on the ground. I have the whole mess inside the boat. There's the welder, oxyacetylenic, with a torch. There's the control unit, it's not fixed yet. There's the RPM change that allows you to change the RPM of the compressor. It's a small board that has a couple of resistors. Normally it stays on the main unit. Here, down here, she stays over there inside the fastons, and then the two wires that are for the thermostat. You can choose between the common one and then the various RPM, 2000, 2.5, 3000, 3.5, depending on the type of the evaporator you have inside the fridge. Now the next step is put the gas in, but since I'm in Europe, I have to wait for a guy that has that's a normal pump. Here in Europe you have to be authorized to handle the gas, the R134A. Right now she's sucking the vacuum. Right now it's only on the tube. That's the maximum the pump can do. It's a two-stage pump, and when I open the valve, it sucks more. Now normally you leave her like on for I don't know, 10 minutes, 20 minutes, then you turn it off, you let the humidity to settle in, and then you turn it back on for a couple of minutes, and afterwards you start charging the gas. You close the valve, the main vacuum. Here we have only the the gauge, it's fucked up. I lent it to a friend. Now the cheap and dirty way is to use a cheap thermometer that goes under -10 and so on with his now I'm missing the batteries. In this one my friend is taking the batteries, and put it on the evaporator on the place where normally the thermostat stays. The thermostat in the boats, you have one of these that has a small wire like that stays on the evaporator and it goes down. Right now it's not fixed. I took it out. I thought and I just bent it to keep in touch with the evaporator. And when you recharge the gas, you bring the bottle, the big bottle. When you recharge the gas, you put a thermometer on the place where normally the thermostat stays. That's the point. Now I don't know if I managed to see it on the video. Okay, so now it's this one is the tube that's going in, and you have, this is the return, and this is the capillary that goes there. The gas starts to evaporate here on this place. It goes all around the evaporator and then goes down and comes back from the back. on the part where it comes back, where you have normally the two holes to put the thermostat wire on, that's the highest temperature on the evaporator. So that's the point that you're interested in, and there you have to put the thermostat probe. And when you start charging the gas, you start blowing at small bursts. Just put a little bit of gas in, just another little bit of gas in, just another little bit, and watch the temperature. When the temperature it starts going down, you give them like 1 minute, 2 minutes between bursts. The temperature, you'll see the temperature going down, and it's going down, and it's going down, and it's going down. Once it at a certain point will just go down and start rising up when you push more gas in. When you push more gas in and the temperature is going up, that's the point where you have to stop charging the gas. Now, the thing you have to know about the both fridges, there are two types of compressor. The main types that you'll find inside the boat. The danfoss, it's the maker, and you have BD50F, and then you have the BD35. I don't know if you can see it well. Aesthetically, at the first glance, there seems like they're the same thing. The difference is inside the compressor. The BD50, it's a little bit more powerful. It draws more power, but it pumps more cold inside. Then you have the condenser. This is an old one that used to stay like on the other one, like this. The condenser, and it used to have the fan behind the condenser, so the air it's sucked from outside, goes to the fan, blows over the motor, and then goes away. On this side, this is one of the most costly one. It's a Frigomatic. It has a lot bigger condenser inside. There's more area where to do the condensation. Now, there is a... Sorry about the movement of the camera. There is a law in the thermodynamics. Now, let's now the one that you will find in most boats are the danfoss. This is a BD50F. This another one, it's a BD35F. You can only see the three. I did not scrape. Aesthetically, from outside, there seems to be the same thing, but the BD50, it's a little bit more powerful. It consumes a little bit more energy, but it is more powerful. You'll find it on the freezers and so on. And each one of them have the condenser. This one is the condenser that I took out from the other one. Used to be welded, how it was, like this. Used to be welded like this. And this one, it's a small condenser that is born for fridges. But this one, the other one that's from Frigobot, it's a more expensive one, has a lot bigger condenser than the other one, and it is a lot more efficient. There is a thing in the thermodynamics that if you take this this radiator condenser and you'll attach it on a piece of aluminium or iron or copper or whatever you like, and you start heating up. You put it inside like a bucket or on the oven at 120 degrees Celsius. The time that will take from this small radiator to heat the whole piece of copper, iron if they're connected or there's some kind of liquid or something that connects them. The time that will take to heat it up will be like, I don't know, 5 minutes. If you take it out from the water and you leave it in a cold air at 30 degrees, the time that will take to get cold the piece of iron will be like 5, 6, 7 times more. So releasing the heat, it takes more time and energy than acquiring the heat. So that's why having a bigger condenser on the compressor of the fridge, or having a water cooler unit, it's more important than having it's more efficient than having an air-to-air system. Now for the electronic control unit, they're the same unit. They make a couple of models. This must be an old one, 101 N02110. They're all the same. For BD50 or BD35, 35 is the same unit. You have one connector with 3 pins, and all you have to do is put it like this, and it has a small screw that keeps her in place, and that's the electronic control unit. And electronic control unit, it's a nuclear factory by herself inside. This what makes her so efficient, this type of compressor. You have the first stage that pull up the tension from 12 or 24 volts, because those units will go with 12 or 24 volts. It will boost it up to 60 volt for the low RPM, 2000 RPM, and it will boost it up to 90 volts on the highest RPM, 3500 RPM. This is an H bridge, and those transistors and everything else is the part from the control for the control unit, for the booster and everything else. It has a microprocessor inside. This is like a big factory inside. It's really well thought in a time where the brushless motors were not in the market used like today. Today you have the brushless motors, the 3-phase brushless. You have them everywhere, in the drones, in the small cars, even in power drills. They started to put it in. But when they first designed the danfoss BD35 and BD50, it was like the most innovative thing. Of course, they could have make it run directly on 12 volt without the boosting stage, but have it run on 12 volt, they would have to use power transistors, a lot more power, and the efficiency of the whole system, bigger wires, beefier wires, and so on, and the efficiency of the system will have dropped consistently. So in order to keep the power consumption low, they opted for the boosting stage and have the control unit and the motor running at 60-90 volts. Now the RPM of the motor, you'll have to put it, it's everything depending on the type of the evaporator you have inside. You'll find on the most producers' sites the combination chart table. If I manage, I'll put the picture over the video so you can see the combination chart and how it goes with the RPM.